Okay, so let's, if you have your syllabus handy, you can look at that, but I'm just going to navigate to the section here. I just want to show you, we're not like really out of whack that much, but we are just like a week off. So we have completed the test one, and we talked about basic layout concepts. And I was actually thinking about not doing that lab, but based on the quiz that we just got back and watching you guys do some of your measurement stuff last week, I think that this lab will be a good lab to do. So we are going to go ahead and do that lab too, as we were scheduled. It's just a week different. And so everything here on the syllabus is basically going to push down 1 week. So I want to just talk about this basic layout concepts in conjunction with the lab we're going to be doing, which we talked about last week. And I might start some of the building structure stuff, but we're not going to do that building layout until next week. So I'm going to focus on that next week. And then the utilities will go down a week. And this test that is scheduled currently for the 18th is going to bump down another week. So everything's going to push a week, and that's not going to be a big deal because we have time to move stuff around here. The only thing obviously that won't change is the test schedule for the third test. Okay, so as we get closer to this test, that test 2, I'll let you know the exact date on that. And I might actually even publish a new course outline for you so you can follow it. So, but just remember that everything's going to be off a week for now. So in terms of the labs, if we look at the labs, we are going to be doing this lab, I think, this basic layout concept. So this will be our second lab. So this control traversing that we did last week, that one worked off very well. I was really pleased with that overall. We'll take a look and see if there's any questions based on that in a minute. So then that report was due, I think I told you 2 weeks. So a week from this Thursday is when that one will be due, okay? And then we'll be pushing these other ones down. So one of these labs we're probably going to lose, and if, you know, we'll decide when we get down here, okay? So that's not gonna be a big deal. All right, does anybody have any questions about that? And of course,
I just wanted to reiterate the last lab we just did
yes,
is due a week from this Thursday.
correct. Now, if you get it done early, Jacob, and you want to turn it in, that's fine by me. I already have one group that's pretty well done. Talk to them about it, and you know they got their numbers going and everything. So I do actively encourage you guys to contact me if you have questions, because we did a Zoom session yesterday and worked through some things. So I'm more than happy of doing that with anybody for any reason or any question, but particularly if you're working on that lab and you got some specific issues, you know, take advantage, just shoot me an email, let me know when you want to meet. We can do a Zoom session real simply, and any question you have, I can certainly get that worked out. Okay, so don't hesitate to take advantage of that. Okay, only a few people actually do, and so, you know, so Jacob, long and short, I hope I answered your question. But
Yeah, the only thing we have left to do is to plot it in AutoCAD. But I
okay,
just need to remember how to use the coordinates to do that.
well, there's 2 ways you could do that in AutoCAD, but probably the easiest way is to create your bearings and then just plot it with bearings. So I'll tell you what, I'll fire up AutoCAD and I'll show you guys how to do that here in a sec, because probably other people are going to have that question. Let me get AutoCAD firing up, and then we'll take a look at that real quick, okay?
We just use the distances and then the
Yeah,
bearing.
but you have to just key them in. I'll just show you real quick how we're going to do that, okay? And then I think that'll answer your question.
He loves walking right across your keyboard.
What's that? Oh, okay. All right. So so everybody just understand we're off a week on this, and like I said, that's not a big deal. So for this week, you should have been reading these sections out of the book, chapters chapter 3 and 6, 4, 5, 6, 7 kind of thing. So I'm going to go reiterate some of that today. If you want to, there's a section that he's got about communication on chapter 2 on pages 217 to 229. I will pick up and talk about that next week, but that really has more to do with your layout. Okay. So once we start actually doing real building layout, that kind of stuff, that'll be important. Okay. I hear somebody talking. Is there a question? No questions? Okay. All right. So is everybody good on this before we move on? Other material? All right.
Yeah.
Okay. So let me jump over here. You should have also in Blackboard, and I just made that active today. The weeks are available up to 7. So this has got the stuff that we may get into some of these layout concepts today. I really want to focus on finishing the other stuff up on week 6 so that we're ready for our next lab. Okay, so if you want to look at this ahead, you can. The handouts are out there. There are some readings and some stuff I would like you to do for that as well. Okay. All right, so let's specifically see if there's any questions pertaining to Lab 1. Let me go ahead and now open that one up. And as far as the write-up, or I'll talk about that AutoCAD plotting thing here in a minute. Let me see, that would have been in here. Okay, so we did this last week. Like I said, you guys did a pretty good job. I really was pretty pleased overall. I think that was good for me to see that you guys really knew what you were doing there. Okay. So we measured the angles, did everything we said, just what it said here. Do focus in on the stuff when you're doing the results. So I'll see if there's any questions based on that. But you know, when you calculate your angular misclosure, you're probably not going to come up to a pure number that's going to divide easily by 4, okay? So what you need to do is when you divide your misclosure by 4, make sure that you get it so that you get seconds and not decimal seconds. I want your angles to the nearest second, okay? So if you have to put a little bit more or less adjustment in one angle, that's fine. Just make the decision and do it, okay? For the direction that you're starting with, you're given a starting direction of line AB of northwest 1230.00. So when you come around with that and use your adjusted angles, you should calculate a direction for each line. So you have AB, BC, CD, and then D back to A, all right? Just like we did in class. Once you do that, you're going to calculate your latitudes and departures, your original latitudes and departures, which will allow you to calculate your air enclosure and your precision. So remember, precision's not going to be perfect. Okay, it's not going to be very good. I know one group got a number. Does any other group have a number yet for me?
So ours is really, really bad.
Like how bad, Jacob?
It's 1 foot to 1,242 feet.
That's not bad. I mean, that's the other group was 1 in 1,800, something like that. So I mean, when I say it's not too bad, it's not too bad based on the way we did it. Okay, I told you guys up front it wasn't going to be good, right? I mean, in the real world, we would know that we could not deal with that kind of precision. We would have to redo it. But for you guys, this is fine. Okay, it was just about the process. Okay.
All okay, I was just a little worried about that.
No, don't. Remember, specifically, all of this class in general is about how to do things, not the quality of what you're getting. Okay. So I'm not worried about the quality of the product. I'm just worried about the quality of the experience. So it's important for you to understand what you're doing. And also, when you do your final report, I want you to discuss why you think those errors occurred. Why do you think you had a low precision? Okay. So in general, if you had a precision like that, why do you think it was so bad? Anybody throw out an answer?
There's a lot of factors.
Okay. Give me 1 or 2.
I think one of them was just the accuracy in shooting, like specifically our distances.
Okay. What specifically do you think made your distances bad?
The way that we We didn't sight on our points the same way each time.
Okay.
Sometimes we sighted right on the block. Sometimes we sighted on the plumb bob.
Okay. Well, that plumb bob would have nothing to do with distance. Okay. So let's first off, so plumb bob would have been related to what?
That would have been for our angles.
Yeah, exactly. Okay. So you hit right there one potential error pitfall was your angles were bad, right? Okay. So that's something you could talk about. Now, when it came up to distance, what do you think was the distance issue? Anybody?
You can just have a little bit of swaying of the prism.
Absolutely. I mean, you're holding that prism. Here's one thing, you're holding that prism and you're assuming that that bullseye bubble on that prism is adjusted properly, right? We don't know that it is. Those things go out of adjustment. So if those haven't been adjusted in a while, which I can tell you, I don't think they have been, you've got two sources of error. The prism pole may not be adjusted properly, and also you got human holding it, which is moving it back and forth. So that's a potential source of error right there as well.
Do they make tripods for those?
They absolutely do. That's one of the things I was saying is when I would run a traverse, out in the real world, when I'm doing that, I actually used 3 tripods, one at the back sight, one at the foresight, and then you had a thing called a tribrac that sits on it, which is actually your instrument sits on a tribrac, and that levels up, and then you put your prism right in the tribrac. So there's absolutely zippo movement that way. Plus you're over the point really steadily. So when you have those kind of things happening, it really, really reduces all those random errors that are going on. Okay. What you guys are observing is a bunch of systematic and random errors, and this is all good to understand because this is what I want you to investigate. Okay. Does that make sense?
It's just so strange that we were only off on our distances by like 0.03 feet. And it's crazy to think that something that small could conceivably throw off our precision so bad.
Well, here's a couple things you're not thinking about. Number one, it's not just angle or distances, it's also angles that are getting you. So you have 2 things that are going on there. Plus, just because you got angles that checked, do you actually know you were specifically right over that point and perfectly level every time?
Definitely not.
Yeah, see, you don't know that. So, there's a lot of things that came into play. And another thing, just inexperience, sighting, whether you had crosshairs focused perfectly or not, all of this stuff comes into play. And another thing that was really bad about that traverse is your distances were short. We were less than 100 feet, right, on a couple of the sides. Is that correct?
Yeah.
Yeah, so that makes a huge difference. I mean, I would never in the real world do a traverse with a side that's less than 100 feet. That's kind of a minimum number. You would never really want to go less than that. So, you guys had a lot of stuff to deal with, to contend with. So the reality is it's all good for our purposes, because I just want you to see these things, how they occur, and that, it's good to understand that, you're not going to just go out there and run control and it's going to be perfect. It's not. You've got to believe in those numbers, though. Okay, that's the one thing. You're not going to say, well, yeah, I can do an adjustment on this and just get rid of it, which you can, but you don't really get rid of it. Okay, you just mathematically get rid of it. All right, does that answer questions?
Yeah, that makes sense.
Okay, so also, you're going to have a really bad closure, but you're going to go ahead and do that compass rule adjustment. Okay, so just make sure, you just follow the rules for the compass rule adjustment, adjust it, and that's what I'm looking for. Okay. Another question, this document right here that I have posted doesn't have the traverse closure sheet. So if anybody is specifically looking for a traverse closure sheet, it's located under week 2. If you go back to your weeks, you can find it under week 2. And down here, there's a traverse calculation sheet. It's got that piece on it, but there's if you want to use this thing right here, you can get an extra one. Okay. So just in case that anybody needs that, it's out there for you. All right. Is that good for that for now, for lab 1, any other questions anybody has? No questions? All right, so Jake, you had a question about plotting it in AutoCAD. I'm going to show everybody that real quick because this is important too, because I do want a picture. And so what you'll want to do is if you have bearings and distances, which is what you should be using, you've got that figure that's kind of a weird shape. We're starting at a point A, essentially. I did give you starting coordinates, by the way, of that. Let's go. Let's see. Make sure you pay attention to those as well. Let's see, those were under week. Those starting coordinates are, where is that? Right there, 10,000, 1,200, northing and easting. Okay. So in AutoCAD, what you're going to do is start at line A, and the first thing you need to do is go into units. So I'm going to go into the units command. All right. Maybe. There we go. I would use decimal units. I mean, if you want to use architecture, you can, but it's just typically simpler for me to just use decimal units, and then I just ignore the foot mark. So if I'm 100 feet, I just type in 100. But since you're going to be in a readout system of angles, bearings rather, you need to set your unit angle up to surveyor's units. And I would probably put my precision up. This doesn't really matter, but if you want to list what you've got, that'll show you that. So you've got your decimal units, your surveyor's units, you're good to go. Then what you would do is go into your line command. Now, if you have your starting coordinate, you could type that in. I'm just going to pick a point. But from this point, I want to travel northwest at whatever distance. So you need to remember when you do this, that you would use the at symbol first because you're saying you're relative to the point you're starting at, which is right there. And it's going to be the distance. So I'm just making up the distance. Let's say we measured 100 feet. So I'm going to put 100.00 less than. So this one is a north 12 degrees. So notice there's no degree symbol on the keyboard. You have to remember that you got the D, either uppercase or lowercase. I think it was 30 minutes and 00 seconds. And then you're going to be west. So I would enter that, and notice that puts me, whoops, like that. And then I'm going to have another line. I would be attached to that. Let's see. No, I do the same one. So I'm just going to guess. Let's say that bearing was 49 degrees northeast. So then I would say at whatever my distance is, 200 feet at north 49 degrees east. And then it just, whoops, I did that wrong. I don't know if you guys noticed, but I put the at symbol twice. I should add the less than symbol. So if I type that, that's going to be, you're going to have that same problem if you're not careful when you key it in AutoCAD. It can be a pain. Let's see if I can paste that and put that. So there, it shot it out. Okay. So what you're going to do is you're going to come around, you're going to have that, and your lines probably won't close. That's not a big deal, but I would like you to label them. So that would be A, B, C, D. You can put your distances on those lines and or bearings. It would be nice to show both. Okay. So that's what I'm looking for. All right. Does anybody have any questions on that? You should also plot it to scale. So like a 40 scale or a 50 scale, just make sure that it fits on an 8.5 by 11 size sheet of paper. When you plot, don't plot it scale to fit, okay? I want it plotted to scale. Does everybody know what I'm saying there? Was that a question, Cameron? I couldn't hear.
No, sorry.
Okay, all right. All right. So Jake, you asked the question initially. Does that help for AutoCAD?
Yeah, so if I were my starting point, if I were just to put in 10,000 and then 1,200, it would start me at that point. I don't need to like to set the X or Y or anything like that.
Right. Although if you just type in 10,000, 1,200, you said, you're actually going to be X and Y, so you're going to be reversed. Okay.
Oh, that's why. Okay.
But technically the coordinates don't matter because I'm not going to look at your coordinate values. Okay. All I'm going to do is see your ultimate picture. So you could almost do what I just did, is pick a point anywhere. Okay. But when you do your calculations, you will use the 10,000, 1,200 numbers. Right.
Okay.
So
Thank you.
another way to plot this, by the way, would be once you have your coordinates, is you could just type in your coordinates. But if you do that, make sure you reverse them, because otherwise your picture will be mirror imaged to what it actually is. Okay. Does that make sense?
Okay.
So your northing will actually be your X and vice versa. Okay. So you gotta watch that. All right. Okay. Any other questions before we move on? Okay, I'll leave this open. If we have any more questions with that, we can come back to that. Okay, so let's talk about the quiz. I did get your quizzes. Those of you that did it, and I do need to mention that we're a whole bunch of you, probably, I don't know, 50% of you didn't take the quiz. Okay, so that's not a good thing. And people that did take the quiz didn't follow directions. So you've got to, when you get into the quiz, you need to follow the directions. You need to take the quiz. You need to key in the information that it wants on Blackboard, and then you have to submit me a digital file of your solutions. Okay, that's important. So that's how I get internet accountability. It's just the way it's got to be, since we got to go that way. All right. If you didn't do both things, if you submitted me calculations that didn't do it on Blackboard, it was okay this time, but every other quiz from now on, you need to follow directions, okay? And like I said, some of you didn't even bother taking the quiz. I mean, that's not going to kill you, but the problem is that these quizzes are trying to prep you for, what we're getting into, and also helping you when you get into the test, okay? So, make sure that you're doing this, please, okay? And if you have any questions again about anything, just, let me know. You have a question or a problem while you're taking the quiz, also let me know. I noticed that probably 90% of you waited till Sunday night about 10 o'clock to take the quiz, and that's probably not the way to do it. Okay, I would probably do it earlier. That way you don't have issues. But does anybody have any questions on that? Like to go over it?
I got a 9 out of 10.
Correct.
On the quiz, and I just wanted to make sure what I got wrong.
Well, I can send you, if you guys want me to send you, I can't print all these out because these things it's going to just kill the ink on my printer, but I do have them marked up as a PDF file. I can send that to you. So when you get done today with the lecture, if you guys would just send me an email if you want a copy of your quiz, I'll send it to you. Okay. It'll send it as a PDF file, right? Is that okay?
That sounds good. Thank you.
Okay, just make sure anybody that wants their quiz copy, just make sure that you send me an email so I know that I can send it to you. I'm guessing probably a 9 out of 10 that you probably blew your side shot stuff, but your normal loop was good and your misclosure was good. Okay, so that's what I'm guessing. We're going to do levels this week. I need to find, that was a real eye-opener to see that we couldn't do level notes, and these were also homework problems. So we're going to take a look at that. Okay. In fact, I want to do some of those homework problems here in a minute. All right. Anybody else questions? Excuse me. All right. Let's take a look at this upcoming lab that we're going to be dealing with. So let me get
where was the quiz posted at? I didn't even see it to take it.
Well, it was sent to you as an announcement. There was an announcement in your email that came to you Friday. And there's also an announcement. I told you guys first off, Thursday, you're going to have a quiz this week. And then there was an announcement that was sent to you. Okay.
All right.
So you should look back at your emails. And then the quiz occurred in the week, I think it was week 6. Okay. Are you okay with that? You hear me, Casey? I think it was Casey. Is that right?
Yeah, I understood. Yeah, I understood.
Okay.
I'll be aware of it from here on out.
All right. Well, just, I know this was the first time doing it this way for some of us. It was going to be a little rough. Okay. And, one quiz is not going to be a big deal, but we're going to be doing all the rest of our quizzes this way. So count on a quiz every Friday. If you don't see it, if you don't find an email, there'll be an announcement out there that's up that'll be available all weekend. And in the announcement, usually there's a little thing that tells you what week and where the quiz is located. You just click on it and it takes you right to the quiz. Okay, so it's not a big, it's pretty easy, okay? And those quizzes are gonna be available all weekend. So I made it available like from Friday, it was Friday, I think afternoon until midnight at Sunday. So yeah, just make sure we're paying attention to that, okay, from now on. All right. Let's take a look at the lab that's upcoming. So since I will not see you guys before I get a chance to print the labs out, you might want to go ahead and print them out yourself. I'll bring copies with me on Thursday, but you'll find this lab under week 6. Okay, there should be, and if you're not finding it, let me know. But under week 6, there is a lab handout. And it's this guy right here. So I'm going to go through this. I right now have a due date of the 11th. So that's only a week on this one. We should be able to do that. But if I'm finding that we're pushed on that, I can bounce that number back. But the longer I hold these dates out, the longer it just takes us to do everything. Okay. So, all right. So let's look at lab 2. This is the one, like I said, I didn't have a chance to print this out. So, you guys ought to print this out prior to coming to lab on Thursday. And I think everybody hopefully knows we're going to be meeting in room 101 of the ATLC. Unless we have a test, then we'll be back in 152, okay? Also, if you are late for any reason to the labs, make sure that you check in 101 first. If we're still there, great. If not, we're going to be out in the front of the school, not where we were last week. So if you go out to the front of the school where the flagpole is, you'll see us. We're right down below that, where those steps come up from Central Parkway. So we'll be there for the rest of the labs that we're working on this semester. Okay, so let's go through this. I want to show you specifically what we're going to be doing on this lab. This is going to kind of tie a lot of these things together. We're going to do a little layout. We're going to do a little measurement. We're going to do distance, angle, and elevation measurement on this. So there's a lot to do. It's not real tough to do, but there's a lot to do. So we're going to look at, I also want to look at some of the errors associated with this kind of stuff as well. So you're going to be utilizing a lot of different equipment. The total station, of course, this week with the tripod prism pole. We're also going to be using an automatic level and a level rod. Plumb bob steel tape, we'll be doing just a bit of steel taping. And you'll have a tack ball, wedges, and hammer. So I'm going to go through what we're doing here on the distance first, and then we're going to do some angle stuff here. So what this says is that we're going to set up a distance and angle measurement type of thing. So I want you to understand we're going to be actually doing 2 things in this lab. We're going to be looking at measurement and we're going to be looking at layout. And the first thing we're going to do is generate a little triangle. So I'm going to go to this picture and it's going to probably be easier to show you here. So when we get out into the lab, what I'm going to have everybody do is set up at a specific point. So, we've got 4 groups in the one lab. I'll just give you guys a point and I'll say, set up, let's say, for instance, I'll just put a stake in the ground. We'll say you're going to set up at this point. This is where your instrument will be. So what we're going to do from that point is measure out a distance of 75 feet. And you're going to do that with the EDM. You want to get that at exactly 75 feet. And what we'll do is put that in another stake. So what we're doing is a layout, okay? We're not worried about the direction here. I'm just gonna point and say, just make sure you go out this way 75 feet. Now, when I do 75 feet, I'm implying that that's 75 feet horizontally measured, okay? So that's the beauty of the total station. What that will do is that'll give you the horizontal distance. Now, when you guys do this, if you've never done layout with a total station, what you're going to do is basically pace out where you think about 75 feet is. You'll hold your rod at that position and you'll take a rod shot. So you're not driving a stake in, you're just taking a shot where that is. And so let's say when you shoot this distance, let's say you're not getting 75 feet, because if you're just pacing it out, you shouldn't. Let's say you get, actually, you measure 76.26 feet. So what we would have to do, we could take our steel tape and measure back 1.26 feet, put a stake in the ground at that point, and then we would do another distance shot, and you would be hopefully within a couple of hundredths. So we would adjust it so that we would get exactly the number that we want. So ultimately, we were going to end up with 75 feet. Okay, is everybody with me on that point? That's a layout. So if we look at back here, that's what this is telling us to do. Okay, we're going to set up that total station at a given control point, and you're going to lay out that horizontal distance. So then it asks you to take a surveyor's steel tape and record that measured distance between those 2 points on the baseline. So what I want you to do, as just a matter of redoing this, I want you to take that surveyor's steel tape and I want you to measure the distance between these two. Now, it may be a little bit of a colder day, and I think it is supposed to be like maybe in the 40s or the 50s. So you may get exactly 75 feet. You may not get exactly 75 feet. I just want you to record whatever you get. So let's say you record 74.99. That's what you recorded, okay, with the steel tape. Then it asks you also to take and compare the distance that you measured to the layout distance. So if you got the difference there, I want you to compare it, and I want you to tell me why you got a difference. Also, it says use the appropriate taping corrections. So when we're out here doing this taping, first off, you have to make sure that you hold the tape horizontal, all that kind of stuff. I guarantee you guys will try to do slope distances. So I can almost tell you that directly, that you guys will measure a slope distance if you're not careful. The other thing is that the temperature. Temperature is, let's say, 40 degrees. What are we going to have to do with this steel tape distance? Is it going to be correct if we go out and
calculate the difference?
Right. You have to calculate that correction for temperature, and then you have to apply it. Okay. So whatever it is. So what's going to happen is that steel tape's going to be shorter than it should be, right? So your temperature correction should be plus. So if you calculate that and it comes out to be plus 0.1, when you add that to that, that should bring you back to what it should be, okay? So that's the first step. Then what you're going to do while you're set up on that baseline that you have, it tells you to backsight the baseline, set zeros, and we're going to turn a 90-degree angle, and we're going to set another point. So again, we're going to do another layout, and this time we're laying out distance and angle. So you're going to set, you've got your instrument here, you're sighting here. Oops, you gotta do that. You're sighting along this line, so you're looking at that stake and you're setting zeros in your scope, just like we kind of did last week. And you're going to turn an exact angle. Now the difference between what we did last week is, well, you can tell me, did we do a measurement last week, or did we do a layout last week when we did the angle? You can tell me. Is it a measurement or an angle?
Angle?
It was a measurement, okay? Because what you were doing is you had a fixed stake here and a fixed stake here, and you were just determining the angle between, right? So maybe that's what you meant. But what we were doing is we were actually doing a measurement process, okay? In this case, I'm telling you that what we're going to do is we're going to turn 90 degrees here. So in this case, we are laying out an angle of 90 degrees, and then we're going to set another stake here, doing a layout. And this is supposed to be exactly 25 feet. So you're going to set zeros, turn 90, go 25 feet, set a stake. So we've done a layout here, and we've done a layout up here, okay? Now you're not going to check, or you're not going to just assume that that angle's correct. Who can tell me what we're going to do to make sure that that angle's good?
We'd flip the scope.
Right, flop the scope, and then turn that back. When you flop the scope would be basically facing this way, right? And when you then turn it back to this, it should be reading 180 plus or minus. So you'll set zeros again, and you'll return the 90 and just make sure that you're hitting what you said you did, okay? That's just a double center on this. So we're going to double center that. All right, is everybody okay with that?
Okay.
So the next process then is, once you've done that, you're going to occupy the opposite baseline point, and you're going to check some things. So now we're going to do measurement. So what we're going to do is measure the interior angle, and we're going to check the hypotenuse distance, and then we're going to compare those to what it should be. So for instance, when we come here, you're going to occupy this point with your total station. And so now I'm sitting here at that point, and I'm going to assume that I got a good 90 here, and that my distances are 25 and 75. And I'm going to measure two things. I'm going to measure this distance. Why didn't that work? Okay. Oh, I'm in a erase mode, not a draw mode. Okay, so I'm going to measure this distance using the EDM, and I'm going to measure this angle using the total station. Okay. And can we predict what this number is going to be and that number is going to be? Or should we be able to predict what those are?
Yeah, we can use a trigonometry to predict it.
Right, because actually here, if you assume that this is a 90-degree angle and you've got 25 exactly and 75 exactly,
Pythagorean theorem.
Right, we can get that with Pythagorean theorem. So what you're going to do, we're going to see if we laid this out properly. Okay, that's what we're doing. This is a check. This is called a diagonal check, and we're going to use this process next week when we do a building layout. So if you take 75 squared plus 25 squared, take the square root of that, you'll get a number. And if you go out and shoot that with your EDM and you don't get that number, that's telling you got an issue. So if we take 25 squared and 75 squared, take the square root of that, we should be coming up with, it looks like, if I calculated that right, 79.06. You go out there and shoot that with your EDM, and you're getting 79.08, you're not exact. So one of two things probably happened. Either some of your distances are wrong or your angle's not right, okay? So the other thing you're going to do is you're going to set zeros here, right there. You'll turn this angle around. You'll measure that angle, and you'll be able to convert it to this angle. And you can use an arctangent relationship, 25 over 75, to determine what that angle should be versus what it is. Okay, so what I want you to do is I want you to compare what you came up with what you're looking at. Okay, does everybody understand that process?
Mm-hmm.
So we're going to investigate layout, and measurement, and see how those kind of two things work together. So we're doing horizontal distances, horizontal angles. Okay, that's what we're getting into there. And some steel taping stuff, which we're going to finish off talking about today as well. All right. So the next thing on this lab is we're going to run a we're going to do a trig leveling application. So what I'm going to have you do while you guys are set up at this point, I have a benchmark somewhere down here, and I have another bench up here, and you're going to basically shoot that with your total station and then shoot that. And if you know this, say this elevation is whatever it is, then you'll be able to determine what this elevation is using trig leveling. Okay, so we're going to do that. And the last thing we're going to do is run a benchmark or run a closed level loop. And I'll tell you, potentially that'll be the hardest thing for you guys to do. It always seems, this differential leveling seems to be pretty hard for most people. So it's not that big of a deal, but just to show you, that's what we're going to get into. I'll show you what we're going to be running here real quick. So you guys, I definitely want you guys to understand your notes. If you might want to look at, we're going to look at some more note stuff today. But between now and Thursday, just make sure that you understand level notes. Now we're going to just do a loop. We're not going to do profile leveling, but next week we'll be doing profile leveling. So just to kind of give you a little schematic, got the front drive in the front of the school, and there's steps that are running up from Central Parkway all the way up to the top. And out here is our lab. So I have 4 control points, and they're kind of in a diamond shape. I think this is 101, 102, 103, and 104. Whoops. And those are iron pins that are in the ground. That was my traverse that I set up. And right in the middle, which is visible from all of these points, is our benchmark. And it has a given elevation on it. So what I'm going to have you guys do is run a loop. If we have time, we'll do the loop through all 3 of these. There's quite a bit of elevation change from here to here, and then from here to here. This is quite a bit downhill. So this is probably a good 30 feet or 40 feet between 104 and 102, maybe more than that even. And these guys are pretty much about the same elevation across here, but it's all a hillside that's dropping in that direction. So I'm going to have you start out at the bench, and you're going to run a loop from 101 to 102 to 103 to 104, and then back to the bench. So you'll start here, work it to here, work it here, work it back, and then come back, and that'll be a closed loop. Now, if we're running out of time, what I might do instead of that is have you guys just go from 101 to 104 to 103 and then back. So if we may just skip that one if we don't have time. Okay. So we're going to be dealing with this is not going to be a simple thing because excuse me, you're going to have multiple setups, possibly 2 setups here, 2 setups here, a couple setups. So you're going to have probably 5, 6, 7 setups. So that's going to be the process, and then learning where to set your level and how to read the rod. That's going to be the 2 big things. Okay. So we're going to be utilizing the same note process, just we won't be utilizing profile leveling. Okay. So that's what we're going to be doing, and it'll take probably every bit of 3 hours to complete it. So make sure that you're there on time. And you know, the one class starts at 9. I'll have everything ready. We'll assemble. I'll just go over this real quick, and then I'll get you guys out there. And then when the other group comes in, they start at 12, and then we go till 3. Okay. So on the results on this, it pretty much tells you what you need to do. I don't think you'll have any problems on this, but you know, if you have any questions, you need to let me know. There is one thing. This report, which is not like last report, but this report does have questions to answer, and you need to make sure you answer questions because this is like 10 or 15 points of the lab points. So out of your construction surveying and layout book In chapter 3, you're going to answer problem 18 and 25. In chapter 6, you're going to do problem 19. Okay, and all of that stuff gets submitted. When you submit your stuff, your lab, don't forget you always are going to give me a copy of your original field notes. And any calculations that you perform, that's also part of it. Okay. Also, when you do your questions, there are going to be problems where you're doing math. Don't just throw an answer down. Okay, I want to see what you're doing there. So write everything out, because if the answer's wrong, the whole problem's wrong. Okay, I need to see everything. All right, any questions on that? All good. There's a set of level notes here too, which you'll need. Okay, I'm going to run copies of these. I will have a copy for everybody on Thursday, but if you have a chance to print this out at home, you might want to go ahead and do that. Okay. And probably also bring a copy of Lab 3 with me, so that you'll have it ahead of time. That way you won't have to print it out. I don't like you guys to have to print out everything if you don't want to or don't need to. Okay. Any questions? No questions.
Definitely have more questions when we actually get there.
Absolutely, I agree with that. But I think if you understood what I was going through process-wise, I think you're good for now. Then, okay. Just make sure you know how to do level notes. We're gonna go through that today too. So, what I'd like to do now is handle these problems right near. Okay, so I gave you these homework problems to do. Chapter 14, problem 4. 13, 4, 11, and 13, and then chapter 7, 20, and 22. So let's start out with chapter 4, problem 14, and let's see if we can work through these. I will work through any problem that you want to. So actually, probably ought to work through all of them because they're really, did anybody do these by any chance? I'm hoping.
Yeah, I did them.
Okay.
There's just one problem I had issues with, I think.
Okay. All right. Well, cool. We'll tell you what. I'm just going to start, and we're just going to work on. Okay, and then see. Let me go to chapter 14 first, real quick, and we'll see if there's I think that one was a real simple one. So if you go to the book, chapter 4, problem 14, what it's telling us. Let's see. So the problem states for 14, it says, what is the source of error if a chain is labeled as a 100-foot chain and it's actually found to be 100.01 feet when compared to a calibration baseline? So what are they asking you there? Anybody? They're really not asking you to calculate anything. You're just asking you a hypothetical question. So the tape is calibrated at 100. And it's actually found to be 100.01 feet. That's its true length. What's happening there?
That's an instrumental error.
It is, and it would be called an incorrect length of tape error. And would this be systematic or would this be random?
This would be systematic.
This would be systematic. That is correct. Now, here's the thing you guys need to understand too. With any error, you need to classify yourself or think about it, whether it's systematic or random. And if it is systematic, that means you can correct it, but you have to measure what's causing the mistake, okay? What's causing the error in it. And if you don't measure that, well, then it might as well just be a random error because it doesn't matter, okay? Also, if you don't have any knowledge of the fact that this is going on, that can be a problem. That's, of course, why you're taking a class like this, so you can investigate that kind of stuff. Okay, so that's good. All right, so let's jump into chapter 13. There were problems 4.
Yeah, because that's different from like if it was that off when it was like a temperature change. That's different from it being that off when it is just like as it always is.
Correct. So what you assuming, and really, he didn't say anything about temperature, right? He just was saying, they're different. So you're assuming that you're looking at them at the same temperature, right? And you're not really doing any measurement. You're just basically laying one tape next to the other, and you're saying, hey, this is out by 1/100 of a foot. And that's really how they calibrate them anyway, essentially. It's just comparing one steel tape to another steel tape. Okay, so yeah, that's a good observation there, right? So I'm going to go to chapter 13, problem 4. And Shelley, which problem did you have a question on? I'll get to yours eventually.
I don't think I understood what 4 was asking.
Okay, well we'll do that first, and then I'm gonna work 4, 11, and 13 because some of you probably didn't look at these yet, and these are good problems. Okay, so all right, so problem 4, it says that your chain. He uses the term chain, by the way. I think I explained where that came from, but that was the old term when they actually used a chain. Surveyors, we still call steel tape 100-foot tapes chains. When I was working, we always called them chains. It was like, yeah, go get the chain. And everybody knew that was what we were talking about. But he says that you have a 100-foot long tape. It's laid on the ground that is sloping at 4%. So he wants to know what is the horizontal distance if the slope is if the slope measurement is 300.23 feet. Okay, so what he's doing is he's saying, look, you're measuring a hypotenuse, and I want to know what is the horizontal distance. Okay, so let me draw a picture. When you do problems of a lot of these nature, any of that type, you usually want to draw a picture. So I'm going to go ahead and let me clean this up. And I might have already answered your question, but let's see if. Okay, so again, you got to assume, and I'm looking kind of on edge on this, so not straight down or anything. You also got to understand, he's saying you got a piece of pavement or whatever that's sloping like this, and you want to know what a horizontal distance is. So I would have to project this down, like that. So this is the distance I'm after. My horizontal distance. So we're assuming that this is a horizontal plane right here. And it says that you measured along the sloping ground 300.23 feet. And that this guy is 4% off the horizontal. And actually, does it tell me whether I'm going up or down 4%? Does it say that?
It doesn't look like it.
It doesn't. Does it really matter?
No.
No, because if we mirror image that triangle to be down here, I'd still have the same horizontal distance. Does everybody see that? So it's in this case, it doesn't matter. Now, who can tell me what would you do to handle this? What's one way we could do it?
You can convert that 4% slope into an angle.
Sure. And then once you have an angle, if I've got this in terms of a theta angle, this is a simple cosine relationship, is it not?
Yeah.
Because we're assuming, of course, that this vertical line is perpendicular to the horizontal surface, right? So and I went over this last week, how do we convert that to an angle? Well, what does 4% mean? What does that mean?
4 out of 100.
For what?
4 feet out of 100.
Okay, further.
Like,
I'm okay with what you're saying, but I'm not okay with how you're saying it. That's all.
It would be 4 feet per 100 feet horizontal distance.
Okay, still not hearing what I want to hear. 4 feet of rise over 100 feet of run. You basically, you said the run, but you didn't say the rise. Okay. And by the way, this is unitless. So this could be feet per foot, inch per inch, meter per meter, right? So basically you're saying this is 4 and this is 100, right? So to get that theta angle, that's an arctangent relationship, because tangent is opposite over adjacent. So in this case, the arctangent would be 4 over 100, or 4/100. So if we do that, we would take 4 divided by 100, take the arctangent of that relationship, and I get, you guys verify this, 2.2906 degrees. That's what I'm coming up with. Does anybody agree with that?
Yeah.
So also be careful, by the way, if you got your calculator, if you're in radians and you do that, you're not going to get that number, okay? So usually it's pretty whacked out, so it should make sense that that's going to be a pretty flat number, okay? So now all it's saying is, look, I've got this horizontal that I want to solve. I want to solve this horizontal distance. So what we have is the cosine of theta is what? Horizontal over hypotenuse, is that correct? Is that right?
Yes, it'd be Jason over hypotenuse, so yeah.
That's what we want, right? So really the hypotenuse in this case, if we just replace this number, let me just get rid of this. What I really want to do is just solve for the horizontal distance. So in this case, what I'm actually doing now, come on, turn that off. All right, so my horizontal distance is going to be equal to my slope distance times the cosine of my theta angle, which is 2 degrees, 2906. So if we took the cosine of that times 3, hold on a minute. What'd you guys come up with? Anybody get an answer?
299.99.
Yeah, correct. And it should be less, right? I mean, visually you can see that your slope's always going to be higher than your horizontal. All right? Does that make sense now? Everybody okay with that? Shelley, you see that now?
Yes, thank you.
Now let me ask you this. Is this a layout problem or is this a measurement problem?
Measurement.
Measurement. Because what we did was we measured this. Where do you think this came from? In reality, where would you get that number? How would you know that that pavement's at 4%?
That would be like on the site plan.
Could be, but do you assume that they built it exactly for us? Okay, here's my question. That's a really good point. But you go on the road and it says, oh, that road should be at 5%. Do you know that it actually is, right?
Definitely not.
Yeah, you don't. Well, you don't know, right? That's what I'm getting at. So you're assuming we're doing a bit of an assumption there. That's all. Okay, that's all I'm getting at. So that was good. That was good. You'd be surprised though, if you go out and measure roadways that are built with any precision, the way they do them nowadays. If it says 4%, in general, it's going to be 4%. I mean, it can waver a little bit through it, but it can be pretty close. Okay. All right, that was a good problem. Let's jump into problem 11. So this one, problem 11 is a little bit more involved kind of thing. It is dealing with what we call a, well, actually, it's just, this one's simple. 13 is the one we're going to do, but let's look at 11 first. So it says we have a concrete slab that is measuring 10 feet by 85 feet, and we're going to lay it out with a steel tape that is known to be 100.03 feet. Under standard conditions. So that means everything, there's no sag, there's no temperature correction, everything's the same. So what we want to know is what should be laid out. So let me draw a picture of this. Again, pictures are really instructive when you're doing these types of problems. So we're assuming we're going to do a building slab that is, let's see, it's pretty narrow. It's going to be 85 feet long by 10 feet wide. Now, what kind of distances are these, by the way, assumed to be?
Horizontal.
Yes, okay. And I said that the other day, and you need to really focus on that. When you see any numbers on a set of plans, like house plans or highway plans or anything, those numbers are horizontal distances and horizontal angles, and not, slope. Even though, like on a highway, you're going up hills and down hills. Those numbers, those stations, that kind of stuff is all given that way, unless we see what's called a profile, which we're going to see that actually. Okay, so it tells us we're using a tape. It's a 100-foot. It's a 100-foot steel tape. That's what it's calibrated at. Okay, that's called the nominal distance. Nominal. Nominal means in name only. Okay, so it says it's 100 feet, but the true distance is 100.03 feet. So we have to lay this slab out with a steel tape that's longer than it should be. So what we have to do is what's called an incorrect length correction, and then apply that. Okay. So if you go back to the notes that we looked at last week, we said that the incorrect length is L minus L prime divided by L prime. And that gives me the amount of change per foot. And you have to recognize that, if you remember, that L in that equation, little l, is the true distance. And L prime is your nominal distance. So what we're going to have here when we plug numbers in, so we know that looking at that, you have 100.03 feet minus 100 nominal feet divided by 100. So this gives me the amount of change per foot. So this is going to be feet per foot. Okay, feet on the top, feet on the bottom. It's unitless, but it's basically feet per foot. Let's see what's happening here. So if we take 100.03 minus 100 divided by 100, I get a number 0.0003 feet per foot. Okay, or you can just assume that it's unitless. So what is this number saying? This says that in 1 foot, you got that amount of air. In 2 feet, it's going to be 2 times that. In 10 feet, okay, so if we multiply that by 10, what do we get?
Be 0.003.
So in other words, that is the amount of air in 10 feet. So do we worry about it or not? Do we have to deal with it, or do we worry about it?
It's so insignificant that you wouldn't even be able to measure it.
Exactly, because our steel tape, we're only measuring to what?
Only to the 100th.
Yeah. So this one's negligible. So we can ignore this because it's too small to deal with. Okay. So in other words, if we measure 10 feet with our steel tape, for all intent and purpose, it's 10 feet. Everybody see that? Now let's see what happens when we do the 85. In 85 feet, we might see something, because in 100 feet, we definitely do.
It was 0.0255.
0.0255, so we'll just call it, actually we could just round it up to, we'll call it 2.6. That's good enough. Okay. So this one's got something about it, right? We have to deal with this. So the question is, what do we lay out? Okay, who can tell me? What number would you lay out? Because we're either going to add this or subtract it. Are we going to use 85.03?
Should it be 84.07 or no 97?
Yeah. Now here's why. I gave you another equation the other day that I said the true distance is equal to the recorded distance or the measured distance plus the correction. Okay, right? This correction is a plus correction. Now the true distance here is 85 feet. We don't know what we're measuring in the field, but we know that we're adding what? 0.026. When we bring this guy over to the other side, what happens is you have 85 minus 0.26, and what that gives us is 84.97. That's what you would lay out to get 85 feet with a tape that's too long. So if you recall last week, and that takes a little time to think about, what we talked about was the problems like this equation right here. This is for a measurement. And so what you're getting is a measurement correction. When you're doing a layout, the signs flip, okay? So if you would have added this number to 85, this distance would have actually been what?
85.03.
No, it would have been 85.06 because you're already 300ths long and you're actually compounding the air double, right?
Correct.
Yeah, so you got to be really careful with that. Okay, does that make sense?
So if you're ever over, like on your tape, then you can always just assume that your corrections are going to be negative. Because
yeah, but if you, because here's where it's set up right here, Jake. Notice if your true distance is greater than your nominal distance, this guy will be plus, which is basically what you just said, right?
Yeah.
If your true distance was less than 100, then this correction will be minus. So this equation gives you the plus or minusness over here if you plug the numbers in right. Okay, that's the thing you got to be really careful with.
And then when you would, at the very end with the last formula, then you would flip it.
Only if it's layout.
Okay.
Okay, because this is what I'm laying out. This is the true number, 85. Okay.
So you just need to make it so that it's perfectly 85.
Right. If it's a measurement problem, you don't flip anything. If it's a measurement problem, 85 would have gone in here. Okay. You get what I'm saying?
Okay.
Okay. So we'll have to handle that a little bit more. The reality is, guys, we don't do a lot of taping correction stuff anymore. This is just good stuff to know, though. It's just good stuff to really take a look at. So, okay, let's take a look at 13.
How did you get that 100.03?
That was given. Okay, so this was given in the problem. The problem states that you're laying out a slab that's 85 by 10. Okay, that's given. And he says you're using a nominal steel tape. He says you're using a 100-foot surveyor's steel tape, but it's found to be a true distance of actually this. So these four things are given.
Okay.
And then what you're charged with is determining what your layout distance is. And we had to do it for both cases, right? We had to do it for the 10 feet and the 85 feet. But for the 10 feet, it was negligible, so we just ignored it, okay? But we couldn't do that with the 85 feet because it really started to come into play. So as your distances get longer, proportionally, you're going to have more error, right? And so that's what's happening. That's exactly what's going on there. Does that make sense now?
Yeah, it does.
Okay, so let's look at 13. So 13 is basically very similar. It says you got a steel tape chain that's known to be 100 points. Let me erase this. So I'm going to start writing this down. So they tell us that we have a steel tape that's known to be 100.3 feet. So we're assuming that we're using 100-foot surveyor steel tape. So that's my, again, that's my nominal distance. But he just told us in this problem that it's actually 100.03. So he's using the same number. So that's the true value of this tape. And then it's used to measure the distance between two building corners. Okay. So if the distance between those corners is supposed to be 268.33 feet, okay, so they're giving you a distance of 268.33 feet. This is a also true distance. That's what it's supposed to be between building corners. And the temperature, when you do this, going to do this measurement is 97 degrees Fahrenheit. They want to know what distance should be laid out. So this is a layout problem, and this is the distance we should be measuring. Okay. So what's happening in this problem? How many corrections do you have going on here?
You got to correct for the temperature.
All right, so we have a temperature correction there going on. What else?
In the length.
Yeah, so there's an incorrect length. So we've got two corrections that we got to apply. Now the way you do this is it's very easy. You just solve each correction and then you add them together algebraically, and then you just apply one correction at the end. So you don't have to correct your distances like twice. You just do it with one kind of thing, okay? So what we have to assume, because it doesn't tell us this, but last week I told you, you have to assume your initial temperature is 68 degrees Fahrenheit. That's your calibrating temperature, okay? So that's the temperature that the manufacturers supposedly use, and that's considered room temperature. That's why they use that number. So that's not always true, but we'll use it. So this is this correction is K, T minus T initial times L, okay? So in this correction, K, does anybody remember what that stands for? K, or sometimes they use alpha.
Is it T initial minus T or T minus T initial?
It's always final minus initial.
Okay, I had it written wrong.
Final minus initial. Well, I think I might have had TF or something in yours, T, but I'm calling this the initial temperature right here, right? And that's important that you get these right here, because this is going to give you the sign. If you blow those, that'll give you the wrong sign on that, okay? What about K? What is K?
Is that the temperature?
It's what?
That'd be the coefficient of thermal expansion.
Right, and that's material based. So for steel, again, that would be something you'd have to look up. I remembered it as 5 zeros, 1, 2, 3, 4, 5, 6, 4, 5. And for centigrade, if you're using centigrade, it's a different number. So you got to be really careful with that. So here, we're going to use this one for steel. It's hotter, so it's 97 minus 68. So notice we're getting a positive correction times L, which is the true distance, or actually that's our measured distance. So we're going to 68.33. So let's see what we get when we crank that number. Looks like I'm getting plus 0.05, basically 0.2 feet. So basically 5/100ths of a foot long. So what that says is in 268 feet on a hot day, you're actually 5/100ths longer than you should be. Okay, does that make sense?
Yeah.
Okay. So the correction for incorrect length, remember it is L minus, what do we use, L prime divided by L prime times the length that you're going to use. So in this case, this is L prime, and this is L. So we just plug that in. And again, we're using the 268 because that's the measurement that we're required. Notice also, this is going to give me a plus correction as well. So let's see what happens. Here's what I came up with. You guys verify this. (800ths of a foot, basically, which is about an inch. Is that what you guys are getting?
Yeah, that's good.
Yep.
So the correction or the systematic error due to the incorrect length is greater than the systematic error due to temperature. Okay, that's important to understand there. And what's happening is truly both of those are happening at the same time. So what's going to happen is we're going to add those two together. Okay, now you could realistically have one that's negative and one that's positive, and when you add them together, temperature cancels out incorrect length. That can happen. But in this case, they're both working in the same direction, so that's going to be a problem. So now we're going to use this. The actual distance, the true distance, is going to be equal to the measured distance plus the summation of your corrections. Okay. So what I know is, in this problem, I know that between the building corners, I have to have exactly 268.33 feet. I want to know what I need to measure in the field, so that's L, plus the sum of the corrections. So I'm going to have a plus 0.502, whoops, and I'm going to add to that a plus 0.850. So when these guys get added together, you're going to get a number that's going to come over negatively. So when we actually measure this in the field, let's see what we come up with. You're actually going to, in the field, measure a distance of 268.20, essentially, with your steel tape. That's your layout distance. Okay. Do you guys have any questions? These are really good. They're good problems in general, not just because they're steel taping problems, but they're just good problems because a lot of the stuff you see in other classes, you guys that are taking statics or will be taking statics, you're going to see this equation right here because it comes right, it comes from strength of materials. And actually a lot of these do. So anybody questions? So that's what it should be. That's based on the plans. This is what you're going to lay out with the with the steel tape. Okay. Let me ask this hypothetically. What would you use in an EDM? So you shot a distance with an EDM. Would you have to do this stuff with an EDM?
No, because the errors would be different. It would be instrumental.
Well, there are natural errors.
Oh, and then laying out of the prism.
Well, this we wouldn't have a problem with at all, right? In an EDM, that one would not exist.
Yeah.
There is a temperature thing going on there, okay? What's happening is temperature affects your column of air that you're shooting your carrier free beam through. And what that does, you can think of air like a fluid as far as your EDM is concerned. And so if you're shooting let's say you're shooting a bullet through molasses or you're shooting a bullet through water, there's going to be a difference. It's going to slow the velocity down of that bullet, right? So it's kind of the same thing with light. As that temperature and pressure change, that's going to change your air column. It does produce what's called a parts per million correction, what we call a ppm correction. And it's small, parts per million, but it does make a little bit of a difference when you shoot distances on EDM, but you don't have to worry about this specifically. Okay, so there is a ppm correction. I think you mentioned, did I hear somebody say something about the prism?
Yeah, the like where you set it, but also how it settles and the temperature.
Well, the prism actually has what's called an offset associated with it. So if you look at the cross section through a prism, if that's my prism, when the light strikes through that glass, it comes in and then it bends like this and then it comes back to the EDM. So they set the prism center with what's called a prism offset so that that distance is exact. So they typically use 0 millimeter, which means this guy's pushed just where it needs to be. One of the common ones they use is 30 millimeter offsets. And that can be either a plus 30 millimeter offset or a negative. So you enter this number into the total station, and you enter this number into the total station, and it adjusts your distances accordingly to what your true correction should be. But let me tell you this can be a problem. If you're using a 30 millimeter prism to do your measurement with, but your EDM is set to 0, what's happening every time you shoot your distance?
It's adding 30 millimeters.
Yeah, it could be adding or subtracting, correct. Now, here's another question. That's a good answer. But let me ask you, does it matter how long that distance is? Are you always getting 30 millimeter bust, in other words? So if let's say, measure 50 feet versus 500 feet, am I still getting 30 millimeters?
I think so.
You are, correct. So because this air is what's called a constant, this is called a reflector constant, okay? So again, whether you're measuring 50 feet or 500 feet, it'll still be a 30 millimeter bust in your number. But 30 millimeters is really insignificant in 500 feet. But 30 millimeters in 50 feet is a little bit more significant, okay? So it can be an issue. If you guys think about it, when I'm out there,
have affected our measurements for our traverse we just did?
it could have if we're running prisms that have the wrong constant with the setting in the EDM. It's possible, sure. That's why it's really dangerous when you get equipment from different manufacturers. People buy all these prisms all the time and they just assume that their total stations are like set to 30 millimeters. That's what a lot of people use, but that's not necessarily true if your prism's set wrong. So you gotta watch that. When we get to lab on Thursday, if you remind me, I'll show you. Usually on your prism, it'll tell you what the millimeter stamp is, and we'll look at the parts per million correction and the reflector constant for you, just so we can take a look at that. I mean, most of these are pretty insignificant. And to answer your question about throwing your traverse out, that probably did not throw your traverse out that much. It could have. I doubt it. I think it's a lot of other things we talked about earlier on. Okay, to be honest with you.
Yeah.
That was a really good observation though that you brought up there. Okay. All right, questions. We've covered some good stuff here today. Anybody have any issues on that? No questions?
Yeah, I'm good for now.
Okay. So the other two questions were out of chapter 7. And I had 759 and 760. These were level problems, level note problems. Let me see if I can find the issue. Let's see. Okay, so the one occurs on page, if you have your books, because I don't really have these scanned in or anything. If you have your book, problem 20 is on page 759. And we're looking at problem 20, and he gives you a loop that starts at a benchmark and that it ends at a benchmark. Did anybody do these problems? I did ask you to do these last week.
Yeah.
Okay. Did you get me a misclosure? By any chance?
Yeah.
All right, let me clean this up a minute. I'm not going to write the whole notes out, but I will go over some of this. And if you haven't had a chance to do this, you might want to look at it. So this begins at a benchmark. I think he gives you a benchmark Birch, he calls it. And he ends at Birch. So everybody should be able to answer this question. Is this a loop or is this a line of levels?
This is a line.
No, no, it's not. It's a loop because it's what?
Oh, the second part, he goes back.
Yeah, it goes back. Okay.
Okay.
Now, the way he writes those notes, you got to watch it because it's like he's got it two separate ones, or he's got an out and a back return. So just be careful with that. Okay. I would take those notes. If you want to use the book to do it, you can, but I would transfer them into the note sheet that I've given you. It would be helpful. So also, if you look at these notes, they're to 3 decimal places. Can anybody tell me what that would typically mean? So for instance, the first rod reading, one of the first rod readings is 6.113. So what do you think about that? Are you guys measuring that much?
No, it would only be like to the 100th.
Yeah, typically it's to the 100th, okay? Now, there are ways to get to this place, but you would have to use a precise level rod, which we're not using, okay? But if you are running these, okay, this loop was either using precise leveling or it was probably metric, because metric people do use 3 decimal places, okay? So just
metric.
What's that?
That's what I was going to say, but I didn't want to feel stupid. And
No, you don't feel stupid. It's good. I mean, because no, that's true. This is it doesn't even say that, and we don't know that, but it's probably
it doesn't
metric.
even say what the units are.
It doesn't say that, right? So we don't know, but I'm just saying, just hypothetically think about this when you see that. We're not going to measure it, and we're not going to do this in the field either, but we're going to go to the 100th, not to the 10th, 100th, 1000th thing, okay? So this is probably metric. But my initial question, and I think Shelley, you told me you had a misclosure. If
Yeah.
you sum your back sites, I came up with a plus 0.006. Is that what you get?
Yes.
Okay. All right. So this has a pretty tight misclosure. So it could be a precise level loop because that's the kind of stuff those guys would be dealing with if you were looking at that. So check these notes out then. If you haven't had a chance to do them, look at them. If you have any questions, submit it to me, okay? Because I need, again, we're going to be running levels on Thursday, and doing the notes is easy, but when you guys get out there and start setting up the level and trying to figure out what's a backside and what's a foresight, it's gonna seem really like you don't even know what you're doing, okay? For some of you, that's going to take a while. So master the notes so that when we get out there, you'll know what's going on, okay? So you can use this as a guide that you know what's going on. I'm going to look at the second one, which is on page 760, and I ask you to do problem 22. Now this one also starts at a benchmark. It starts at benchmark, looks like it's 3055, and it ends at benchmark 30, 55. Okay. So this one truly is also what?
It's closed.
This is a closed loop, right? So now this one is also what you call a profile level notes sheet. So this is a case where you guys want to make sure that you ignore the, he calls them side shots, SS. Some people call them intermediate rod shots, and I just in my notes I just call them a rod shot. And he's even got a plus and a minus for your backside plus, foresight minus, and minus on your side shot. So he's kind of helps you with that. Do your loop first, okay? Solve your misclosure, and the misclosure on this one is turned out to be a plus 0.02 feet. So if anybody did those, that's what you should come up with. Check your loop misclosure first, and then come back and do your side shot values. And that was the one thing I noticed the most on people that had problems with the quiz. They tended to do the loop right, and then they blew the side shots. Okay, so let me do something here real quick. Get to last week's lecture notes. Let's see. Week 6. Okay, so on this, let me see. I guess I don't have them on here. All right, here we go. Let's look at this real quick. The biggest problem that you get into, let's see, I want to go backwards. That's not going to let me. Hold on a minute. Okay, so this is a traditional notes. These are your simplistic notes. Let me slide shot here from current slide. So this one, basically what we're talking about. So when you're doing this kind of a loop, sum your backsides, sum your foresights, always do this first. Check that loop misclosure first, and then come through and do your notes. When you're doing profile leveling notes, like such as this, ignore your rod column. Don't even mess with it. The first thing you want to do, first thing I would do, is sum backsides and foresights. Well, that doesn't work in this case because I'm starting at benchmark A and ending at benchmark B. So this is a non-loop. This is a line of levels, okay? But I still have a way to check it because I have a published value of B here. I was able to get my final elevation minus what it should be. So there is a misclosure here of 300ths. So once you do this and you know that you've got good HIs, okay, and again, a lot of people I noticed mess this up. This HI is used to calculate all of these. So you're going to store that number minus 9.3, that number goes here. That number minus your HI goes here. This number minus your HI goes here. What a lot of people did was they got the loop right and they blew this. So what you're doing is whoops, this right here. So my loop first, and then I'm coming up with these next, okay? So just watch that. We are going to be doing profile leveling quite a bit, not this week, but next week from that point on, okay? So that's it. That's good for today. Next week, I'm going to jump into doing building layout and those kind of things, but I want to focus in on this stuff. So if you have a chance, go ahead and print this out so you'll have that ready to go and read through it. I went through it, but you should, so that way if you have any questions, you're good to go with that. If you're still working on traverse closure calculations and you have some questions for me or you need anything, shoot me an email. I'll be glad to. I can set up I can either look at your notes or I can set them up, set up a Zoom conference and we can go over that, okay? And if you guys need to look your quiz over, just shoot me an email and I'll send you a PDF file of what I marked up, okay? Otherwise, any questions before we get out of here today?
I'm good for now, thank you.
All right, so I will see everybody on Thursday, okay? And then, by the way, there were two people that missed the lab one. It is possible to make that up. You need to contact me because I have a student that has volunteered to help you run the lab. So take advantage of that, but we're gonna have to figure out what days and times and that thing works for everybody. So if you were one of the two students that missed the lab, you need to make it up. Otherwise you have a 0 right down. You don't want too many zeros in your labs. It's gonna really impact your grade, okay? All right,
Are we able
so
to make up the quiz?
I don't normally do that, Casey. A quiz isn't gonna be a big deal. I'll be honest with you. So I'm not going to worry about it this week, but let's just focus in on this for the weeks that are coming up. Okay. Yeah, quizzes are only 10%. They're not going to, or 10 points. You may miss a quiz. It's not going to be a big deal, but tests and labs are major. Okay. And I'm not going to let a quiz impact your grade. Trust me. Okay. So that's not what I'm looking at. But I need to move on. I got so many other things to deal with. I hope you understand, but okay.
Sounds good.
All right. Okay. Anybody else questions? All right. Well, I'll go ahead and stop the share. I'm going to go ahead and get this formatted, and you should see the lecture out there probably within an hour. And otherwise I'll see everybody on Thursday.